Okay, students. So we will be taking this live session, and welcome to the live session of Sustainable Power Generation System. This is live session 10 being conducted on 1st of October 2024. This course is taught by Professor Pankaj Kalita, and he is associate professor in IIT Guwahati. I am Rohit. I am PMRF scholar at IIT Bombay. I'll be taking this live session. So what we will do, we will wait for some more time before we start the session. So if you have any questions or anything which you want to discuss, so please feel free to write your questions on the chat box, or you can also ask your questions here. So before we start, I think we can wait for some more time for others to join. Okay. guys. So, did you saw this origin and nature of tidal energy? So, basically, tides are the phenomena of nature. So, because of the gravitational attraction between Earth and the Moon, these tides actually occur. So, you can basically say it, count it as a geographical phenomena. However, there are several other things that has to be understood because tides contains energy. So you can actually harness this energy. It's a kind of renewable form of energy. So you can imagine Earth is covered by a huge amount of water, a huge mass of water, and this water is basically moving. So you can see here the bulge which is creating. Okay, so this is exaggerated. It is not like so much, but you can shape is something like this. Okay, so 70% of the tide producing force is because of the moon. Okay, and because of this bulge, you can actually, so Earth is also rotating on its axis. So that also actually produces a kind of effect that is very similar to tide. Okay, so because of this and moon, there is always a centrifugal force, okay, and gravitational force that basically acts. And then this centrifugal and gravitational force acts in resonance, then you get a quite huge amount of tide, but with a high tide. Okay, so basically tides are produced by the gravitational attraction of the moon and sun acting upon rotating earth, and the moon exerts a large gravitational force on the earth, and that is very much the surface water is pulled away from the earth on the side face of the moon, and at the same time the solid earth is pulled away from water on the opposite side due to rotation of earth moon system producing a centrifugal force. Okay, this is how. So tidal phenomena occurs twice every 24 hour 50 minutes, so you can divide it by 4. So between a low tide and high tide you get 6 hours at 12.5 minutes duration. Okay, okay. So basically we are not very much interested in tide, we are interested in harnessing energy from tide. So how can a tidal plant actually work? So basically, you can build a dam, barrage, or dike. So whenever tide comes, you store the water, and then there will be sluice gate. You feed the turbine, and then use a basin during high tides or emptying it during low tides. Bulb type power turbine generator set, steel cell containing an alternator, a special Kaplan turbine with variable pitch blades. Okay, this is something like this. Okay, so high tide is there. You store the water in a basin. Tidal basin is this. So whenever it flows, so a turbine is rotated, and then so water held till the suitable head is created, because for generating electricity a suitable head is actually necessary. Okay, so sequences are also altered during filling operation of the basin. The sloping nature of single basin makes ebb generation more productive method. Okay, now you have single basin double effect schemes. Power is generated on both flood and ebb generation cycles. Flood is basically when you are moving to the tidal basin. Ebb is when you are moving to the, so there is a reversible turbine. Whenever water moves from here, so generated, power is generated. Then whenever it moves back, also power is generated. So sequence is like inverse sluicing to fill the basin. So basically inverse sluicing is like this: gate opens and holding period, ebb generation. Okay, outward sluicing to empty the basin. Okay, and then holding period and then flood generation. So you have to remember this sequence because this can be asked in quiz and exam also. Two basin linked basin scheme. Okay, so there is low basin and high basin, and there are sluice gates. So this is ocean. So you want like consistent type of power output. You don't want to wait for a time like 6 hours and 12.5 minutes. So this is for that. So we store the water here in the high basin, then flows back to the low basin, then it flows back to the ocean. This is how it works. To maintain continuous power supply, linked and paired basin schemes are used. This scheme consists of two basins, one topped up at high tide, other emptied at low tide. So when high tide is there, high basin is filled, and low tide is there, it is emptied. Okay, thus a permanent head is created between the two basins. The water flows through a turbine, high basin to low basin. Two paired basin schemes. This is something like this. So basically, both are independent, not like dependent here. Okay, one scheme generate electricity on flood, other on the F cycle. So basically, when there is a flood, there is electricity generation from there, and then when there is F cycle, then there is also electricity generation from there. So in both the cycle, whether it is high tide or low tide, so electricity will be generated. Okay, so output is almost continuous. There can be sometimes when in between there can be variation found to be economically inferior to single basin schemes. Okay, tidal current turbines. So these are some of the tidal current turbines. Okay, these look like this. Okay, Gorlov helical turbine is also there. Then lunar energy tidal turbine is also there. Tidal current extract kinetic energy in moving water. So this is quite like we see in hydroelectricity also. Tidal current turbine must be able to generate during both flood and ebb tides. Structural load when not generating electricity. So now here comes the question. Okay, so question is a single basin type tidal power plant has a basin area of 2 km. Average range 13 meter. Power generated during ebb cycle. Turbine stops operating when help falls below 3 meter. So tidal range is given. 3 meter below 3 meter power will not be generated. Calculate average power in single emptying process. Turbine generator efficiency is given. Estimate average annual efficiency energy generation of the plant. So this is quite easy question. You just have to understand what is being asked here. So, okay. So, keep trying. Let's see who is able to solve this question actually. Okay, so this is how it is generated. And then rated power is generated, then you have to energy available in single emptying. So you single emptying, you know, half into rho a g r square 1 minus r square. So you can put the values here. Rho given, a you know, g you know, r square minus r square. Okay, so calculate it and see how much is the value. This will come around something to be around 160, this much. Okay, now the question is estimate the annual average generation. Okay, so in one ebb cycle, basically one ebb cycle is of 12 hour and 25 minutes. Okay, so consider 25 upon 60, so that is 12 hour and 42 hours. This is okay. So number of ebb cycle you have to calculate. So basically in a year, number of ebb cycle is 365 into 24 is the number of hour in a day, and total hours 24 into 365, and one ebb cycle is 12.42 hours. Okay, so that comes out to be around 706. Okay, so average will be, just multiply this into this. Okay, and into zero point 0.7 because rated efficiency is this, and then divided by 3600. So answer will be in kilowatt. Okay, kilowatt hour. So that comes out to be around 2.2 into 10 to power 8 kilowatt hour. Okay, so estimated annual average electricity generation. So that is quite high. So this much unit of an electricity generated from tide. So you can imagine one unit, or basically a normal typical household consumes one or two unit. No, I think let's say 5 to 10 units per day. So that is high, I think, not 5 to 10 units, 3 to 4 units per day at a max. Okay, so you can see the amount of units basically generated. 1 kilowatt hour is 1 unit. Okay, so tidal energy has got a lot of power. The basic function is utilization. Okay, uh, basically now we are moving towards wave energy. So few factors you need to remember, these factors, because the questions can be asked in the exam. So speed of the wind, faster the wind is traveling, bigger will be the wave. That is obvious. Time of the wind, the wave will get larger, longer the duration of wind hitting it, and distance of the wind. Farther the wind travels against the wave, the bigger will be the wave. Heaving floating type plant. So this is kind of heaving floating type. So wave is like upper and lower, like this. So this goes up and down, and then this is kind of a piston which can actually have a compressed air storage or something that can be used then to generate electricity, because this compressed air can be then pass through a turbine, air turbine, gas turbine or something. Okay, so then we have pitching type. So this is something like pitching type, ratchet and wheel mechanism. So okay, in pitching type, waves strike horizontally on the float piece or flap. So this is flap. Several more nodding ducts are hinged to common flexible linkage to form a nodding duct assembly. This is something like this. Okay, and then they moves up and down, so it turns the duck in the direction of motion of waves. So it moves up, then this moves, then down, then this moves, something like that. The duck swings backward with the trough of the wave, and once the peaks have passed over it, it then oscillates about its axis. The ratchet wheel mechanism converts the motion of the duck to the common shaft, and the power collected Individual ducts used to drive a generator through linkage and gear mechanism. The shape of duct is optimized to extract maximum power. Main advantage of this system is that the duct can flip and recover again. So this is one of the advantages. Heaving and pitching float type. So you can actually have both. Okay, so this is something like this: heaving and pitching float type plant. Rolling and heaving both can be converted into unidirectional motion using Rachel wheel mechanism that we see in the this pitching float type. Okay, oscillating water column. So this is one of kind of innovation in which due to the waves the water can move up, and then when it passes down, or it can compress the air, and then air can actually flow through a turbine to generate power. Okay, so air velocity can be increased by reducing the cross section of the air channel slower. Okay, surge devices. So this is also there. So basically, due to the wave motion, the water force into it, the extra water flows through it, and then it rotates the turbine. Okay, so that is also a uh, arrangement that can generate electricity. Okay, so basically, I think this will solve later. So if there is anything, any questions, so this is one of kind of a question. So if there is anything which you want to ask from this question, so please feel free to ask. Okay. Show you guys a video of tidal energy also. So sometimes this goes out. So don't worry, guys. This whole setup is actually being recorded. This is kind of weird sometimes when nobody joins, then it kind of logs out, and then it is very difficult for us to actually track. Okay, no problem. So let me show you guys a video of uh, if I could have video from the YouTube. So it kind of something like this. guys, you could easily see here like how the video very beautifully explains how the thing are actually shaping the tidal power plants, how they are facing difficulties from locals or maybe due to some environmental issues. But yeah, the kind of resources they bring as a renewable is quite huge. So the acceptability is increasing nowadays. More and more tidal plants are coming. They are fewer in numbers, but you can see them increasing in future. Because the main reason why we should focus on tides, because they are predictable. They are wind energy. So wind is not predictable, but tides are predictable. So this is why it should be focused into. So basically, you can see and observe the problem challenges associated with tidal energy. So yeah, there are some challenges, but I think the kind of technology it brings in, the kind of clean, sustainable energy it brings in, that actually matters a lot when you are talking about tidal energy, getting power from these type of sources. So yeah, one of the things that can be thought about is to actually look into the cost of the equipment. However, the presenter suggested that life cycle cost. So you guys can actually go and see the life cycle cost of the system. So she presented that life cycle cost can actually be less than. So I am taking a pen here. So this is not typically tidal energy. It was last. Okay. So it can be less than 0.1 dollars or pound per kilowatt hour. So that still is very less cost than other uh, renewables. So yeah, that can be looked into actually. So life cycle cost can be one thing because environmental things, putting a price tag value on environmental things is quite difficult, and life cycle cost can actually present a broader picture of the things that we want to see. Okay. So if you have any queries regarding this question, so you can ask, or I think we can see some more videos on waves, if you suggest. That was really a great video, I think, which explained how or why the plants, let's say, yeah, not how it works. So let's say, yeah, So this is what you just saw actually, how the waves and this tidal energy is actually working and creating a kind of positive atmosphere for the systems, for renewable systems to harness the energy from the ocean. Yeah, there are some challenges. I am not saying that there are no challenges at all, but not only challenges related to tidal energy or energy security or something, but continuous supply of power, intermittency, or but also to biodiversity surrounding the tides, which was actually explained a lot. Okay, so if there are any questions which you want to ask, please feel free to ask. Okay, so we can have a kind of break where you can ask your questions, and then we'll move to the numerical questions. So we will solve a numerical and then we'll move towards the quiz questions. Okay, so that numerical is very important. So it's kind of the numerical which you solved earlier. Okay, so I will be solving this question, numerical question. Okay, thank you. Thank so have a break, and if you have any questions, please feel free to ask. So we have been doing this question here, this wave energy plant. So kindly do it and see whether you are able to get the answer or not. So you have to calculate the total energy in the wave. So I will let me repeat the question. The question is, a wave energy plant is set up near the coast of Indian state of Gujarat, and the progressive sea wave has an amplitude of 3 meter, wave width 90 meter, and time period 6 seconds. Density of seawater can be considered as 1025 kg per meter cube. So density is already given here, so you don't have to assume anything. Calculate the total energy in the wave, and the second thing is that you have to calculate the wave power, and if dolphin type wave energy, so there were different wave energy converter that we discussed. So if dolphin type wave energy converter are used, along a width of 650 meters, so calculate the installed capacity of plant. This is third. And fourth is, if the capacity of single dolphin type wave energy converter is 100 kilowatt, so calculate the number total of dolphin type wave energy converter required. So these are some of the questions which you have to solve. So this is the last numerical which I will be discussing here from the lecture slides, and then we'll move towards the quiz questions. So see if you are able to do it. Okay, so you just have to apply the formula here. Okay, so I'm giving you the formula like a hint, and then you have to calculate it by yourself. Okay, so amplitude is given, that is small a is given, rho is given, g you know, acceleration due to gravity, and then you have to calculate the wave area. So wave area, the formula you know, wavelength into wave width. So wavelength is also given, wave width is also given. So wavelength you have to calculate, that is 1.56 into t square. Okay, and time period you know, 6 seconds. So based on that you can get the wavelength. After you get the wavelength, you can calculate the area lambda into width, wave width. Okay, so do it. Don't worry, you will be able to do this question. This is very just a conceptual question where the concepts are basically applied. Were you able to do this question? Okay. So take out your calculator. Let's solve this question now. Because we have to solve the quiz questions also. So let's solve it now. Don't worry, you will be able to do this question in no time. Okay. So first thing you need to calculate is this. The first thing is you need to calculate the lambda, that is wavelength. So wave area actually. So for that you need to calculate the lambda. So 1.56 into t square, that is 6 square. T is time second of the time period, sorry, time period in seconds. So if I could see this is something around 56.16 meter of wavelength. Okay. Now we have to calculate wavelength into wave width. So wave width is given 90 meter, multiply it with 6. Okay. You know the wave area also, wavelength given. Now you know the amplitude A, that is 3 meter given in the question. G equal to 9.81. Put the values rho equal to 1025. Okay. So always check the units. All other things are okay. So if you calculate, put this value in E, that is E equal to 1 upon 2 rho G A square A. So if you put all these values, that you will get around 228.7 megajoule of energy. So that's a huge amount of energy that you can extract from the wave. So if I could have to produce this much amount, so let's say normal bituminous coal has generally 20 to 30 in between. So you can say 23 megajoule per kg of coal. So to produce this much amount of energy, you have to burn 10 kg of coal. So see, you can imagine the kind of emissions that you are saving from going to the atmosphere, CO2 emission, greenhouse gas emission by burning of coal. So this is what is actually required. That's why renewables are actually important. So now, so question 1 is solved. Now you have to calculate the wave power. So total energy, you know, and then just divide it by time period. Okay, that is wave power. So they're divided by wave power, let's say P. So 228.7 upon 6. So that comes out to be around 38 point something 12 megawatt or something. Okay, so power is in watt, energy is in joule. Okay. Now you have to calculate the installed capacity of dolphin type wave energy converter. So dolphin type wave energy converter. So for that installed capacity calculation formula is 1740. So you just have to remember this formula because this type of question can be asked in the exam also. Then amplitude square into this T. T is basically the time period and into B, that is plant width. So plant width is given, I think it's 650 meter. So you can put the values 1740. I'm not going to put the values. So if you put the value, that comes out to even 61.07 megawatts. So this is what a single plant can produce. Okay. Now, if the sorry, not single. This is the power of a dolphin type install capacity of a dolphin type power plant if it has a plant width of 650 meter. Now it's asking single dolphin type energy converter is producing this much. So how much can number of dolphin converter is required? So this much is the power which you want. Okay. So this is in kilowatts. So multiply it with 1000 and then divide it by 100. Okay. So that comes out to be around 600, 610.7. So you will require around 611 dolphin type converters. Okay, to produce this much amount of power. You got the point? How to solve this question? These type of questions are quite easy. You just have to practice and see how you can actually approach these questions and solve this question. This was like the previous question which we saw, the deep ocean wave of 2 kilometers. So just you have to think about it. Okay. Okay. So uh, keep watching. If there is any questions, please feel free to ask and let me see, because sometimes what happens, I will keep it. This is what happens actually. Sometimes these, because nobody is there in the meeting, so these sometimes log out actually. So don't worry, the session is getting recorded. So if there's anything which, let me do one thing. What I will do was share my screen. And somebody join, can put it. So I couldn't get to know who else are joining. So yeah, don't worry. Okay, keep uh, watching this, and if there are any queries, please feel free to ask. Okay, so please look into this question for 4 to 5 minutes and see if there are anything which you actually not connecting to. Okay, so are you getting the queries? So on the similar lines, in the quiz question also, you will see that these type of questions are actually discussed and in the live interaction session, and you will be able to solve these questions. So don't worry and just stick to the concepts. Okay, so let's move to the quiz question then. Oh, okay, let's move to the quiz questions then. Okay, I think the questions which are discussed, most of the quiz questions are like this only. So, okay, let's start and let's see if you guys are able to do the quiz questions. Calculate the average power generated during one filling or emptying process of a tidal power project where A is the area of the basin, R is the tidal range. So, I think this is actually discussed in the lecture slides also. The correct answer is actually C. So during emptying title project, okay, filling and emptying. So it's something around 225. A is that is area of basin, R is tidal range. Okay. So should I move to the next question? Filling period, waiting period, generation period, waiting period, filling period. The following given cycle of operation is for which type of tidal plant? So basically single basin, single effect. So you understood this single basin filling, okay, then waiting, then generation because when it's come back, then again waiting, then again filling. So this is what is basically a phenomena of single basin, single effect. So there is also single basin, double effect also. Two basin link, that is more waiting period is less there. Okay. So okay. Should I move forward, or if you have any questions? So I think this was actually discussed here also, like when we were discussing this tidal power, tidal current, this is two basin paired scheme. Okay, so and this is two basin linked scheme, the single basin double effect. So basically, when it goes, then the time this reversible turbine. So whenever there is a flow, then there will be electricity generation, and this is single basin, single effect. So basically, you built a sluice gate. So whenever this tidal wave passes, so it produces power. Then this side the water is low, and then in reversible type there is double effect actually. So okay. So should I move to the look at Indian conditions? Which wave energy technology is found to be most suitable? So this is what was discussed in the lecture slides also. So oscillating water column type will be more suitable for Indian type conditions. Okay. Calculate the wavelength and wave velocity of a progressive sea wave with width and time period. So wave width is given. So wavelength, you know, lambda equal to 1.56 into time period square. Okay. So 25. What I don't know. Calculator. Yeah. Okay, it's just from here. 25 into 1.56. So the answer comes out to be 39. So 39 is answer. Okay, but you need to calculate the second also. Wave velocity also. So you know the wave wavelength, you know, and wave width, you know. So based on that, you can calculate the wave uh, velocity. So try to find out how it is calculated. Okay, so did you got it? So wave velocity basically is represented by c lambda upon time period. So lambda is 39 and then time period is 5. So you can get is 39 upon 5. That comes out to be 7 point something. So correct answer is answer A. Okay. So did you got this? So now most of the questions are basically numerical based, but formula based questions. So you just have to see and solve them. Okay. So don't worry, I am going to solve all these questions for you guys. Okay. So ocean waves in coast of Tamil Nadu has an amplitude of 1 meter. So amplitude is given, A equal to 1 given, time period is given 5, rho is also given. Calculate the power density in the wave. Okay. So first thing which you will do, you will calculate wavelength 1.56 into t square. Okay. So calculate t square is 5. I think this is calculated in the previous question also. So 39 and then wavelength is divided by 5. So wave velocity is 7.8. This is calculated in the previous question also. Now you have to calculate the power density. So energy density, okay, 1 by half rho g into this a square, and then basically you divide the energy density by the amplitude, that is the time period basically, then you get the power density. So calculate it and see if you are able to get the questions, get the answers. Okay, so were you able to solve this question? Okay, so let me solve this for you guys. So don't worry, just stick to the question, see what the question is basically demanding, and then you have to keep trying. Okay, so first thing is you have calculated the lambda, that is 39. Wavelength is calculated also 7.8. Now what's remaining that you have to calculate? So wave frequency is basically, okay, let's say uh, wave frequency is 1 upon 5 seconds. So time period is 5 wave frequency, because this will be required for calculating power density. So energy density will be half into, so density 1000 is given. Okay, then time period, sorry, wave amplitude is given 1 square, and then basically you have to multiply it with g. So that comes out to be around 4905. Okay, this is joule per meter square. Now you have to calculate the power density. So these are density, power density, E upon A, not exactly energy. Okay. So 4905 is the energy density. You just multiply it with frequency, wave frequency. So that comes out to be around 981 watt per meter square. Okay. Solve this question. We see if anything is not understood, or you want to you want me to explain again. Anything which you want to, because you just have to understand the term, because what terms are being used, what are the concepts that are being practiced here. Okay, now if you move to the question 6, so basically array of dolphin type wave energy converter. Width is given, mean amplitude is given, A is given, basically T is given. Calculate the install. I think this was the question which we solved here, no? This one. So this calculate the installed capacity of plant. So installed capacity 1740 A square T into B. Okay. So just put the values equal to 1740 to A square into T, that is time period, and B is width. Okay. So everything is given, put the values and get the answer, and see whether your answer matches with the answer mentioned in the question. Because if they, sometimes there are a lot of questions even I see in the discussion forum also, because some of the questions, some answer may not match with the questions answer given, answer you obtain may not match with the answers or options given. So in that case you have to point it out on the discussion forum so that a change can be made. Okay. So keep see if you are able to solve it. Okay, and get the answer. Okay, so question 9 you have to try it by yourself, and if you try it, just see how different is this question from question 8. Whether when this type of question will come, how will you approach? Okay, this is what you have to do. Okay, so try the question 9 also and see if you are able to solve the question 9. Let me see if there's okay, no connection lost, so that's good actually. So basically, sometimes the connection is lost. So don't worry, guys. This whole session is getting recorded. So whenever you feel anything, please feel free to ask your questions or in the discussion forum also. Okay. So I'm moving then to question 9. So question 9 is basically similar like the power requirement of coastal villages to be fulfilled. So similar question like question 8 here. So approach it by yourself and see if you can able to solve it. Which factors determine the strength of individual waves? So let's solve the quiz questions first, and then I will give you time to solve the question 9. And I'm not going to solve the question 9 this time because I want you guys to have an approach. Okay, so basically, in spite of doing spoon feeding, I want you guys to develop your skill. So that if you try to do these type of questions, then your problem or analytical skill will develop, and you will see how the formula will have to be applied. Okay, this is all you have to do. So basically, the question here is which factor determines the strength of the individual wave? Okay, so which factor determine the strength of the individual waves? So basically all of the above. Speed of the wind also determine time of the wind. Distance of the wind is also important. So all of the above is the correct answer here. Okay. So try to solve the next question, guys. Okay. See if you are able to do the next questions available. Okay, so solve this next question. A cross flow tidal turbine can generate power from so incoming tides only, outgoing tides only, both incoming and outgoing tides, neap tides. So cross flow tidal turbine. So I will discuss. I just show you the picture also. So cross flow tidal turbine can generate power from both incoming and outgoing tides. Okay. So correct answer is C. And then question 12, question 13 and 14 are also there. The time difference between the consecutive high tides and low tides. So you have to remember this. So this can be asked in the final exam also. The 6 hours, 12.5 minutes. Okay. So which of the following is cause for reduction of actual tidal power? Okay. So friction losses of fluids can actually reduce the tidal power. That is universal. Anywhere friction will be there, the power will be lost. Conversion efficiency of turbine and generator. So we were solving the numericals also. So we could see that power generation potential is that much, but because the turbine generator efficiency was about 80%, so we are getting less. Turbine needs to be stored when head falls below minimum value. That was also there in the question. So 10 meter was the actual tidal wave height, and then because below 3 meter it cannot generate power. So all of the above is the correct answer here. Okay, so see if anything which you want to ask guys here. And this is the last question. So before going to the last question, this is very simple. See, if you want to ask something from this uh, slide here. Okay, so no questions. Okay, so last question is The wave velocity is independent of the, so basically wave velocity is independent of the amplitude. Time period it depends, wavelength it depends. So amplitude is totally, wave velocity is totally depends. Because wavelength, you know, the wave velocity was calculated as c equal to lambda upon t. So it depends on lambda and t also. Okay. So thank you guys. Thank you for attending this live session. So we'll meet again on 8th of October. Okay, and I will upload the video soon, so you can also access those videos from there. So thank you for attending this live session.